The 8.2 stuff is back, but instead of converting from US units to other US units, we're going from US units to metric or from metric to US units. But again, they're going to give us all the information we need, all the conversion factors that we're going to need in order to make these, well, conversions. That's it. So I just can't stress this enough. Math is generally, it's just what we want. Okay, so if I look at something, let's go back to 8.2. If I saw something like 5 yards, I mean, you know, if I can use 5 yards, that's great. But if for some reason it's easier to show this as 15 feet, I'm not showing the conversion. But if I wanted to show this as 15 feet, then I could. Again, why would I need 15 feet instead of 5 yards? I don't know. Maybe the smaller units are better. Maybe they're worse. I have no idea. But again, you get to decide why that would happen. But what do you want? Do you want this in feet or do you want it in yards? I don't know, right? So we have to be able to change things. And this goes back to what we saw before. If we see the number 1, which is important because it's the multiplicative identity, and we've seen it something like this, a times 1 equals a, right? Multiplying by 1 doesn't change anything. But again, the question becomes, what is 1? I'll write that down if I can get there. What is 1? Question mark. Because when we get, and I wouldn't say that we're really deep into math right here, but it kind of is deep. Like, what do you want 1 to be? What is 1 to you? I mean, it has a value of 1, but if we go back to what we've been talking about, 1 is something divided by itself. So in the past, what we saw is if you had something like 12 inches and you divided it by 1 foot, it has an overall value of 1. So this one right here, if I wanted to, I could replace it with 12 inches over 1 foot if I wanted to. And that's kind of how we've been doing it, depending on which of the labels we want to cancel out or get rid of, and which one we want to keep. Okay. So remember, if we start, for example, with yards in the numerator like this, we can multiply it if we wanted to. In order to get rid of yards, we would put it on the bottom, and then in order to change that to feet, we would put feet on the top. And yes, it's 3 feet for 1 yard. Okay? So that's what we do, and then we can see that the yards would cancel out, become a phantom 1, however you want to say that, in order to make that 15 feet. Again, what do you want it to be? And that's where we've got to do a little bit of analysis, dimensional analysis, in order to make those determinations. So this is what we're saying. You're going to take a 1, you're going to change it into a fraction that looks something like this. Now, of course, like we saw in the objective, we're going to be changing between US customary units and then metric units. But all of those conversion factors, like this is a conversion factor, right? They show it a little different. They'll say 1 foot is equal to 12 inches. This is what they'll show. But it's important to know that because they are equal, we can take one of them and divide them by the other in order to make this work the way that we want it to. We're going to make the math do what we want. Okay? So, anything divided by 1 is itself. Really, anything divided by, I said that one. Anything divided by itself is 1. That's better. Okay? So, we're multiplying by 1. Really, that's what we're doing. But, again, what is 1? Well, it's something divided by itself, like 1 foot over 12 inches, 12 inches over 1 foot. Or like the last slide, it can be 3 feet for 1 yard, something like that. So these are the conversion factors we're looking at. Now you'll notice that the equal signs become a little freaky right here, right? Like, what the heck is going on here? This symbol, let's see if I can do it by hand. That's not my worst. So that is what, this is an approximation. I don't know if I can spell approximation. Approximation. Okay, that's the symbol for an approximation. Why are we using an approximation? Because these decimals, most of them, are so long that they become so ugly and long that we don't actually want to use the really long decimals. So they've simplified them for us, rounding some of them to the tenths, some of them to the hundredths, and then some of them to the thousandths. It doesn't matter. These are the conversion factors that they are going to give us, so they're the ones we're going to use. And if I were to look at these, probably the one that becomes the most confusing, and there's different ways to do this, but probably the tons, the metric tons. And the reason why this one becomes confusing is because tons is in both. But you have to understand, and they will tell you if they want, or which one they want, but a metric ton is different than a ton. Okay? A ton is U.S. customary, a metric ton, well, it's metric. So there you go. You don't have to memorize these, none of these. You don't have to memorize any of these. In the assignment, on the exam, these all will be given to you. You don't have to memorize, okay? We're just going back to what we saw in 8.2, using dimensional analysis like we've seen, right? We're going to multiply by 1, but we're going to make it something divided by itself with those conversion factors. So if, let's say I wanted to take, I don't know, 100 kilograms and change this. So on the assignment as well, they're going to force you to use dimensional analysis too, right? Where you fill in the blanks and then you gotta put the labels on there. Now again, the kilograms. If I wanted to change this to pounds, okay, so we'll put over here that we're going to change this to pounds. Okay, if I were to change this to pounds, then with this, I have kilograms in the numerator, so I would need kilograms in the denominator of the second fraction in order to make the kilograms go away. If that were the case, then I would need pounds in the numerator like this. See, because now the kilograms are gone, the only thing I'm left with is pounds, so my answer will be in pounds. And it says in the conversion factors that it's 2.2 pounds for 1 kilogram. Let me double check that. So this is a conversion factor. 2.2 pounds is, again, it's approximately, but we're going to say it is 1 kilogram, which means that this overall fraction value is 1. So I'm multiplying this by 1, but I'm showing 1 in a different way in order to get rid of the kilogram label and change it into a pounds label. And yeah, this multiplication isn't even that hard. It's 220 pounds. Boom, done. Okay, that's what we're doing. We're multiplying by 1, and we've seen that you can use conversion factors, more than one conversion factor at a time.
So how did you get 200?
Okay, so we're going to convert 26 centimeters to inches. And on this one, remember that just like we saw in 8.2, it's not always a direct conversion. But let's look at these. Centimeters and inches is length. Now again, since it's length, that means that we don't care about weight or capacity. And if you need to cross those out, then do it, just so you don't have to look at those anymore. But we need to look at this and see if we can find a centimeters to inches comparison conversion factor. Here's kilograms and miles. Nope, that's not going to be any good. I'm going to skip the next one on purpose, but the next one has feet and meters. Okay, now centimeters is close. And if I wanted to change these centimeters into meters, I could from the last lesson, but I don't want feet, so this one's no good either. And then 1 yard, this didn't come out, but that should be in meters right there. Yards and meters, not going to help us either. What we want is an inch to centimeter comparison, which we do have in this conversion factor. So I'm kind of using the process of elimination and how you may have to analyze the conversion factors in order to determine which one you will need to use in your work, okay? So now that we know which conversion factor we're going to use, and we're only using one, this will change centimeters into inches. I'm going to take my 26 centimeters, that's over 1. And so on the assignment, for the ones it's going to force you to use dimensional analysis on, it usually starts this part out for you, but then they're going to show multiply by another fraction, right? Now there's 4 different blanks, and I would start with the units, because with centimeters here on the top, that's correct. I need centimeters now on the bottom in order for the centimeters then to cancel away like this. Now in the conversion factor, you have centimeters, but then you have inches. Okay, so I have to use inches as my numerator here, which is good because we are converting this into inches, right? We're only using one conversion factor. Well, the conversion says 1 inch is the same, approximately, as 2.54 centimeters. Okay, so when I multiply these two fractions, I will have a new fraction, but the label will be in inches. So I'll multiply 26 by 1, which is 26. And then I'll multiply 1 by 2.45, 2 and 54 hundredths. And we don't want that decimal in the fraction, and plus we would want to simplify it. So I'm going to go with the decimal on this one, but again, I'm going to keep my label. And I'm emphasizing this because not a lot of people showed labels on that last exam, and you need to if you want credit. So in my calculator, I just type in 26. You can put over or divide, but 2.54, 2 and 54 hundredths. This will tell me how many inches this ends up being. And on my calculator, it came out as 10 point, I'm going to round this to the nearest hundredth. So I had 236222047. I don't really care about the rest of those decimals. This one right here, if I rounded this to the hundredth, that'd be the 3. The 6 is 5 or more. So the 3, I would have to add 1 and make this 10.24 inches. Yes. Convert 2 kilometers into feet. All right, okay. Try this one out. See how you do it. Good luck. So it's problematic. 2 kilometers into feet. Again, let's just go through the analysis here. It's not weight, it's not capacity. So we can get rid of these. So what the heck is it? Well, in these conversion factors, you got kilometers here. So let's highlight those just so we can see them. We got kilometers there, or kilometers. And then we got feet right here. But there's no direct conversion from kilometers to feet in our conversion factors, which means that we can, if we wanted to, we can change these kilometers into miles and then go back and use from 8.2 a mileage conversion factor into feet. In my opinion, just the way this is, it would be easier to convert the kilometers or kilometers into meters because it's just moving the decimal at that point, right? Then I only need one conversion factor. So with this information, I'm not using this conversion factor. Of course, inches and centimeters is garbage. And same with yards, nothing to do with yards. And so we even see you got meters and meters here. Yeah, so I don't really need to look at yards to meters or the kilometers to miles kind of thing, okay? Now that's some analysis right there, right? I haven't even started doing the work. All I did was some analysis. And so I see that this is the conversion factor I'm going to use. Now you're still wondering, how the crap am I going to use that conversion factor right there? Here's how. Let's take this 2 kilometers, okay? So kilometers to meters, right? So this means that the decimal is going to move, right? We got to, let's show this work. We're going to start with kilometers because that's what we have right here. We're going to end with meters, which is part of our conversion factor, which is just the base unit. Okay, so this means we're going to move the decimal to the right from the kilometers, the 2 kilometers. 1, 2, 3 decimal places. So that 2, it would have a decimal right here next to the 2. And we're going to move it 1, 2, 3 decimal places, which puts 2 zeros on it. So 2 kilometers ends up being 2,000 meters. Okay, now that I have this in meters, now I can use this conversion factor in order to change these number of meters into feet, which I will do. So we're going to multiply this by 1, right? But instead of showing it as 1, it's something divided by itself, so we're expecting a fraction. It's going to, well, let's look at the analysis here, right? We're changing the meters into feet, so I don't want the meters. I will show the 2,000 meters over 1 so we can see that it is fraction multiplication. 2,000 meters over 1. Now I'm going to multiply by meters on the bottom, and that will change feet on the top. And this will, as we want, cancel out the meters, which is what we wanted. Okay, and so what does our conversion factor say? It says 1 foot is 0.305 meters. Okay, so when I do this fraction multiplication, I will now have feet, but I've got to do the fraction multiplication. So we'd have 2,000 times 1 in the numerator, which is 2,000. In the denominator, you've got 1 times 0.305, which is 0.305, or 305 thousandths. I'm doing that on purpose, by the way, reading those out loud, because on the final exam, which is coming soon, we will need to know that information, right? But we don't want the decimal in the fraction, and if it can be simplified, then we should. I'm gonna go with the decimal on this one. And okay, so the decimal is pretty ugly as well. So this is the decimal that I got: 6,557.3. I'm gonna round this to the nearest hundredth again, but I had 0.377049. That's what my calculator gave me. But like I said, I'm gonna be rounding this to the nearest hundredth, which is this 7. The 7 to the right is it's 5 or more, so we add 1 to that 7. That will give me the new value of 6,557, and now it's 38 hundredths feet. Yeah, that changed that now in from kilometers, which we then changed to meters, into feet. So this one is a weight one, so let's do this one together again, okay? Well, how did I know it's weight? Because it's pounds to kilograms. So that means it's not a length, and it's not a volume or capacity thing, right? Okay, so with these conversion factors, we've got kilograms, pounds, again, tons and metric tons. We almost rarely use that one, but of course on the assignment you probably will have to use that. Ounces and grams may be helpful, but again, you'd have to do more conversions than you need. So it could be used, but I'm not going to because we have a direct conversion factor here from kilograms to pounds, or pounds to kilograms in this case. Just keep this in mind, like the last problem, right? If it was saying, hey, convert pounds to grams, then I would still use this to change the 273 pounds into kilograms, but then I would be moving the decimal in order to then change that into grams. You see what I'm saying? So those conversion factors are not given, but as long as you have the notes from both last time and the time before, so 8.3 and 2, then you should be in pretty good shape, okay? All right, so let's get started then. So I'm going to show the 273 pounds, and this may sound weird, but pounds is kind of I just don't like writing it. And I don't like LBS because it looks like 165 sometimes. That's just a handwriting thing, but either way. Okay, now I have this over 1, right, because we can put it over 1. I'm going to multiply this by 1, but instead of showing it as 1, I'm going to make it something divided by itself. So we're expecting another fraction here. And, well, I need the pounds to cancel out or to become a phantom 1. So where the pounds is in the top for the first fraction, it will need to be in the bottom of the second fraction. And yes, the conversion factor changes pounds directly into kilograms. Okay, so now we look at that conversion factor. It says 1 kilogram is 2.2 pounds. Thank you very much. And now we see that the pounds will, in fact, cancel out as was part of the plan. Now I have numbers other than 1 on both the top and bottom, so I am expecting a fraction in kilograms. We're going to change the fraction. We'll use the calculator to change the fraction into final decimal. In the numerator, 273 times 1 is 273. That's just fraction multiplication. In the denominator, 1 times 2.2 is 2.2, or 2 and 2 and 2 tenths. There we go. So in my calculator, yes, 273 divided by 2 and 2 tenths, and it gives me 124, and, well, it'd be like this. The 0 there is just going to keep the 9 to 9, so I'm just going to get rid of it. I'm rounding to the hundredths. I don't know what they're going to tell you to round to on the assignment, but remember, my final answer was, on the calculator, is 124.090909, which probably means it repeats. I don't care. We're just going to keep it like this. No, I'm going to emphasize this again. If it was like, hey, you got to convert from pounds to grams, right? We got this number of kilograms. So I would move the decimal 3 times to the right, and then it would be 124,090, I guess. But this one didn't. Just be aware, if they want you to convert from these kilograms, again, they're not going to say convert to kilograms and then like centigrams or something like that. So if they were to say something like, let's say they had milligrams right here, right? You would then need to know, you'd have to change these pounds to kilograms using this conversion factor, and then you'd have to move the decimal a number of times, in this case to the right, in order to change these kilograms to whatever type of units they want. Now it's your turn. Try this one. Convert 57 hundredths tons into grams. Okay, so let's take these tons. Again, in the conversion factors and the dimensional analysis, we'll always see this over 1, or we should, just so we understand that we are actually doing the fraction multiplication, which we've been doing. Now, the conversion factors they give us, right? Tons and grams, these are weights, so it's not a length or capacity. So we can get rid of that garbage. It's a weight. Now, the only conversion for tons is into metric tons. Now, I couldn't actually tell you what a metric ton is, so I'm not going to use it. What I'm going to do is I'm going to take these tons and I'm going to convert those into pounds, because I have that conversion. I put this up here. 1 ton is the same as 2,000 pounds. So I'm going to change this tons into pounds. So I'm going to use this conversion factor first. Once I get this into pounds, then I'm going to take the pounds and use this conversion factor to change it to kilograms. And once I get these to kilograms, then I can change those kilograms into grams. So three of them. Okay, and we're gonna enjoy this all the way through. So we got the tons. Tons is in the top, so again, I've got to put these on the bottom in order for them to cancel away. And again, I'm going to be changing these into pounds. Okay, so 1 ton is the same as 2,000 pounds. This will get rid of the tons, which is what we want, and we will be left with pounds, some number of pounds. So, in the denominator, you've got 1 times 1, which is 1. I don't really need that 1. But I do want 57 hundredths times 2,000, which on my calculator gave me 1,140 pounds. So I now know how many pounds 57 hundredths tons is. So now that I have the pounds, let's take the pounds and now convert these into kilograms. Okay, so that is this conversion factor. So we don't really need this tons to metric tons or ounces to grams. I will check after this problem just to see if the tons to metric tons would be better, but this is the way that I know. So we're going to multiply this by 1, but instead of showing it as 1, we're going to show it, we're going to multiply this by a conversion factor, something divided by itself. And I do want the pounds to go away, so I will. But with the pounds on the top, I will now have pounds on the bottom, and I'm going to change this into kilograms. Okay, in the conversion factor, it says 1 kilogram is 2.2 pounds, and when I multiply these, I will have kilograms because the pounds will have canceled away. So, in this, right, in the numerator, we've got 1,140 times 1, which is 1,140. In the denominator, we've got 1 times 2.2, or 2 and 2/10, which is 2.2, or 2 and 2/10. So I'm going to put this in the calculator and then divide these. This will tell me how many kilograms I have. And I'm going to keep a lot of decimal places because we need the decimal places. So let's see if I can fit this in here. It's 518.18. Looks like it just repeats. 18. Then my calculator gives me a 2 right there, which I'm not going to need. Okay, so that's it's kind of, I ran out of space, so I made that kind of long. Okay, now I'm going to use this chart because we're going from kilograms. Up here it says to grams. So kilo is going to start us here, and we're going to end at grams, which is the base units. Okay, so this is going to move the decimal to the right. It's an R. To the right, 1, 2, 3 decimal places. So let's go back into that kilograms and move that 1, if I can get that right. 1, 2, 3 decimal places. Okay, so that is going to change that to 518.181. Then we've got the decimal. Then we got these other decimals, 81, 81, 82, like this. Now that is now in grams though, which is what we wanted. I'm just gonna round this to the nearest tenth on this one because, like we said, it's gonna switch back and forth. So that'd be the 8, to the right is a 1, which means the 8 will stay in 8. So our final answer, rounded to the nearest tenth, which we chose to do, ends up being this value in grams. So what is that? 518,181 and 8/10 grams. We did it. That was fun. I mean, I enjoyed that more than I should. But as it turns out, the metric ton thing is going to be a lot better for us. So let's take away this part right here. Yeah, well, I just wanted you guys to know how much I enjoyed that. So let's use this conversion factor. And so I looked it up. It says...
So can I take a picture?
Yeah, so but it says on... I Googled it. But Google says 1 metric ton is 1,000... Oh, I better check. I think it said kilograms. This is, I don't memorize. Yeah, kilograms. It says 1,000 kilograms. So if we're going to convert this directly into kilograms, now we know how many kilograms it was approximately because of all these are really just estimates. What this means, let's see if we can do this kind of small like, is that we were looking at the 0.57 tons. Okay, so this would have been, just going to do the work up here, 0.57 tons, that's T. We would have made it over 1. We're going to multiply that by the conversion factor. It's going to take away tons, and we're going to go to metric tons. I abbreviated that, but I don't know if that's the actual abbreviation for it. But what I do know is that it says that it's 1 ton is 0.907 metric tons. So, skipping a little bit of work here, all right, we'd cancel out the tons, but this would then change this into metric tons for us. Okay, so that's 0.57 times 0.907, which it shows as 500, let me take that back, 0.51699. That's the exact value that my calculator gives me. So a metric ton is 1,000 kilograms. So we would take this value and make it over 1 and multiply it. Right? We want to get rid of the metric tons and change this into kilograms. So it's 1,000 kilograms for 1 metric ton. This is going to change this, right? The metric tons are going to cancel. We're going to end up with kilograms. This would be 516.99 kilograms. And then we're back to the moving the decimal down here. It would still need to be moved to the right, 3 decimal place values. 1, 2, 3. So we'd have a 0 there. We end up with 516,990, but in grams. Now this is an answer, okay? So just so everyone understands, this answer and this answer look very different. But it's because of the estimations that we used were also different. There's may have been some different types of rounding in there, something like that. But just so you know, on an exam, both are acceptable because both of the work are good, is good, whatever. So both of those are good, even though they look different. Again, that comes back to here. Remember, these are not equal signs, they're estimations or approximations. Like this first one that we did this 1, 2, and then a third conversion factor, which was just moving the decimal right there, okay? Again, I wouldn't be looking to use this metric ton to kilogram thing because it's not a conversion factor that we have, and it's not one that I'm familiar with. So you have to decide if that's something you want to use, but again, you'd have to memorize that. So, but yeah, technically, just using the conversion factor that we have, you'd have to do this 3 times. I recommend to my students when they do this, just understand, especially with these types, you may spend more time actually analyzing it than solving it, right? Or you may do one solution, you may do this analysis and be like, you know what, I can't really use pounds, and then you may try to do some other kind of weight conversion. I don't know. But I do know that it does take a long time just to do the analysis part, like sitting and thinking about what am I going to do here. That does take a long time right there. Okay, let's convert cups into milliliters. So capacity, again, this is the capacity that we have. This is one that we got from 8.2. And you can see with the capacities that we have, there is no cups to milliliters conversion. In fact, there's none in the US customary ones, of course. So this means that we've got to convert cups into something else, and then we'll probably have to convert that into maybe liters or milliliters. I'm expecting 3 conversion factors on this one. And not because I've done it, but because I just kind of am expecting it, okay? Because we'll probably have to change cups into something else that's US customary, and then we can change that into liters. Why am I saying liters? Because all the capacities or volumes have liters. You got liters, liters, and liters. The capacities all have liters, and 2 of them have gallons, right? So I'm expecting maybe something to go into gallons, and then finally I can maybe change this into liters. Of course, we do have a quarts into liters as well. Now, does liters help us with milliliters? Yeah, it does. Because then once we get these into milliliters, then we can use this table. If I could make that a little better. Like this, we're going to use this table in order to change it, or just move the decimal, right? Okay, so let's start with our 10 cups. Let's get that out there. And let's start converting that into something. Okay, so yeah, we'll make this over 1 again. But I got to look at my cups comparisons down here. So let's find all the cup comparisons from the conversion factors that we saw from 8.2. Okay, so we got cups to fluid ounces, cups to pints, and cups to tablespoons. Oh, crap. It looks like we're going to have to use 2 of them just to get them into a workable value. Now, just looking at the conversion factors in capacity from metric to US customary, you have gallons, gallons, and quarts, right? I'm not going to be looking, and by the way, the gallons, the liters, doesn't matter which one you use. But I'm thinking that if I can get this into quarts, that I can change that into liters, and then I'll change the liters into milliliters, which means I'm not looking at these 2. Now, again, that may not be so obvious what I just said right there, but if I were to take these cups and change these into pints right here, I can change my pints to quarts, and then I can change the quarts into liters. So that means I'm now looking probably at 4 different conversions on this one. 4. Which means it's 4 times as much fun. And since you can, anyways. So let's do that. So once again, I don't want cups to fluid ounces, and I don't want cups to tablespoons. What I would like is cups to pints. So I'm going to use this one first, and we're going to convert those number of cups into pints. So if I have cups in the numerator, I need cups in the denominator, which will change these into pints, which is, it's not what we want, but it's going to help us get to where we want to be. So that conversion factor says 2 cups will be for 1 pint. Okay, and this will cancel out the cups. I'm going to try to keep these the same color for each conversion. Okay, so in the numerator, this will change this into pints, which is what we do want. But in the numerator, you've got 10 times 1, which is 10. Over in the denominator, 1 times 2 is 2. So 10 cups is the same as 5 pints. Very good. Now that I have this in 5 pints, I'm going to take those 5 pints, make them over 1, and we're going to convert this then from pints into quarts. So that's my conversion factor right there. So I'm going to multiply this by 1. I need the pints on the bottom for my conversion factor, and then we'll put quarts in the numerator. It says 1 quart is 2 pints. So this will cancel out the pints and change this into quarts. Now you can keep the fraction on this one. I'll show both the fraction and the decimal value for this one, but in the numerator, we have 5 times 1, which is 5. In the denominator, I've got 1 times 2, which is 2. So 5 halves would work, or if you'd like, 2.5 quarts as well. Doesn't matter which one you use. I will use the decimal just because that's one that's kind of the type that we've been using a lot here, but it doesn't matter which one you use. All right, so that gets us to quarts. Okay, so we're going to take those quarts. I'm going to use the decimal again, just because we have been. I'm going to make it over 1. And then I'm going to use this conversion factor, which will change these quarts into liters. All right. So the conversion factor, again, I need the quarts to cancel. So where 1 is in the numerator, the second one will be in the denominator. This will change this into liters. 1 quart, it says, is the same as 946 thousandth of a liter. So that's what we have. And the quarts will then cancel away, which will leave me with liters. But I've got to use my calculator for this multiplication. 2.5 times 0.946, or 946 thousandths. And it says that it's 2 and 365 thousandths of a liter. Well, that's nice. But then it says it wants these, it doesn't want liters as our answer, right? We got to change those liters into milliliters. So that means we would start at the base unit, which is a liter, and we would end at the milliliters. So the decimal is going to move to the right.
3 times.
That's correct. To the right, 1, 2, 3 place values. So that liters, we're going to move that 1, 2, 3 times to the right, and we get about the same values, 2,365, but the label has changed into milliliters, and the crowd went wild.
That's the final answer.
It's like an organizational chart where they're like, you know you're going to start here, and that's going to take you to this destination, and then that destination will lead you to this one, and that would lead you into this one right here, and then finally you'd have the answer at the end, kind of thing. Convert 14 liters into gallons. See if you can do this one, and we'll go over it. So you two got different answers. They're different because you use different conversion factors, because those are estimations. So I'm going to show this with both conversion factors. So once again, let's go through this and just determine which conversion factors we need. Definitely not length. This is not a weight. It's a capacity. It has liters and gallons. A direct comparison down here. And that also means that we're not comparing liters to quarts on this one. Let's see if I can cross that out better. That's better. Okay, so one of these two will work, and it doesn't matter which one you use. Both are going to give you an estimated correct answer on this one, okay? So I'm going to do this twice because, like I said, I enjoy this probably more than I should. I'm going to take these 14 liters over 1. Okay, so let's do the first one here. 1 gallon, it says, is 3.785 liters. So I'm going to use this conversion factor. I want to get rid of liters, so where the first fraction it's on the top, it'll be on the bottom on the second one, and we have gallons on the top. Okay, it says 1 gallon is 3 and 785 thousandths of a liter. And we can multiply these, but first the liters will cancel out, and then we will be left with the gallons, which is what we do want. There we go. So in the numerator, 14 times 1 is 14. In the denominator, 1 times 3.785 is 3.785. Okay, well, from here, and again, these are really approximations, even though I'm putting in the decimal, but this would give me this decimal, which is kind of ugly, but it still changes it into gallons, 3.698811096 in gallons. We did tenths on that last one, so we'll do hundredths on this one. So that's the 9. The 8 there is going to add 1 to the 9. So we end up with 3 point, well, that'd be carry the 170 gallons, approximately. So that's one answer. That's one way to do it. But the other conversion factor, which is also a liters to gallons comparison. So this one, again, same idea. We got to get rid of the liters, so I got liters on the bottom, but gallons on top here. But this one, this conversion factor says 1 liter is 26 hundredths of a gallon. So this will get rid of the liters, which is what we do want, and we'll change it into gallons for us. So on the calculator, we do 14 times 0.26, or 26 hundredths, and we get 3 and 64 hundredths of a gallon. Now again, these are different, but since the method is good, both are correct. And again, that's just because these conversion factors are all estimations. That's it. Yeah, so that's our objective. I can convert units between US and metric, US customary and metric. But again, you don't have to memorize any of those conversion factors. They will be given to you both on an exam and the assignment.